السلام عليكم ورحمة الله وبركاته. النهاردة هنبدأ في بارت 2 لليورين اناليسيز. هنتكلم النهاردة على الميكروسكوبيك اكزامينيشن لليورين سيدمنت. هنتكلم على الستيننج تكنيكس. Supravital stains are used to stain cells or tissue while they are living. Other stains applied to dried smear include Wright stain, Hansel stain to differentiate eosinophils from neutrophils, and gram stain to differentiate bacterial organism. So, gram stain to differentiate bacterial organism, gram negative or gram positive. Wright stain والهانسل stain used to differentiate eosinophil or neutrophils. Supravital stain used to stain living tissue and cells. الcommon supravital stain, the first one ستيرنهايمر مالبن ستين، والستين دي made من الكريستال فايولت وسفرانين. So it made from crystal violet and saffronine. The stain is absorbed by cellular elements. The nuclear material with cytoplasm are clearly defined, so it allows identification of cells. So it is used to identify white blood cells والابيثيليال cells والcast. Second stain 0.5% toluidine blue, and this called a metachromatic stain. Why? Because it enhances the nuclear details. It is useful to differentiate white blood cells and renal tubular epithelial cells. So toluidine blue called metachromatic stains, it enhances the nuclear details and useful for differentiation of white blood cells and renal tubular epithelial cells. The third one, 2% acetic acid. It enhances the nuclei of white blood cells, make the nuclei of white blood cells more clear, and lyses the red blood cells. So it is used to distinguish RBCs from white blood cells, yeast, oil droplets, and crystals. The fourth one, Sudan 3 or oil red lipid stain. This stain used to stain lipids. It is an orange-red color, is imparted to both triglyceride and neutral fats. It is used to identify free fat droplets, oval fat bodies, and lipid-containing cells and cast. So Sudan 3 used to identify free fat droplets والoval fat bodies والlipid containing cells and cast. The last one, Prussian blue stain. It is hemosiderine, appears as yellow-brown granules. It's used to identify iron in cells and cast or free-floating in urine sediment. So if there is iron in the cells or the cast, or it is free floating in the urine, we can use Prussian blue stain. It will appear yellow brown granules. Next, we need to discuss what types of microscope used to examine urine sediment. Most commonly method used or microscopy used is the bright field. Microscope used bright field. Appearance of element is dark against a light background. So you will have the background light and the elements will be dark. Advantage, readily available. It is available in all the laboratory. Advantage, object with low refractive index could be missed if light is not reduced or if condenser is not lowered. If you adjust the light to the maximum, maybe the low refractile bodies will disappear and you cannot notice. Care must be taken to ensure that the examination is being performed in the correct plan, and epithelial cells can provide a point of reference. So you need to adjust the light to see the epithelial cells and take it as a reference to see the other elements. Other type of microscope is polarized light microscope. Objects that refract light in two directions called birefractive substance will appear white or colored against a black background. So here in the bright field, the background is light and the element is dark. It is opposite in polarized light. The background is black and the element will appear white or colored. And it enhances the identification of crystals and lipids, oval fat bodies which contain cholesterol that don't have a birefractive properties will appear black. So the object should have birefractive properties, otherwise it will appear black. It will exhibit Maltese cross formation. It is like the body like this and it will show cross like this. This is called Maltese cross formation. Third type of microscope, phase contrast. Phase passing through the object are slowed and the light intensity is decreased. This phase difference, when manipulated by a specialized phase contrast object and phase rings, will increase the contrast of the object due to variation in the refractive index. This enhances details and aids differentiation. The phase contrast microscopy will enhance low refractile elements. If you have low refractile elements that you cannot see with polarized microscopy or bright light microscopy, such as hyaline cast, mixed cellular cast, and Trichomonas vaginalis parasite. These are low refractile. You can see with bright field microscope, but you need to adjust the light intensity to see this, otherwise you will miss. So phase contrast will enhance the examination of these elements. The problem of phase contrast, it is costly and you cannot find in all laboratories. Question number 6. Which type of microscopy refract lights in two directions to stain birefractive substance? Bright field, dark field, polarizing light, or phase contrast? We remember the bright field, the background is white where the elements appear black. Polarizing light, it is used in the elements that have birefractive properties that refract the light in two directions. So the correct answer is polarizing light. The feedback. Polarizing light microscopy relies on the principle of object splitting light into two beams when viewing the slides for analysis. Objects that refract light in two directions, which is called birefractive substance, will appear white or colored against a black background, which is the correct answer. Correct answer is polarizing light microscopy used to examine birefractive substance. Question number 7. The urine analysis supervisor was concerned with the variation in reporting urine constituents among the various technologists. When analyzing the quality control microscopy specimen, What is the most frequently used stain the supervisor could suggest be added to the urine to facilitate visibility and identification of urine constituents? Sterinheimer Malbin, Prussian blue, toluidine blue, acetic acid. As we know that Sternheimer Malbin is composed of crystal violet and safranin, which is absorbed by cellular elements and frequently used to differentiate between white blood cells and epithelial cells and cast. So the correct answer is Sternheimer Malbin, which is more frequently used for examining the sediment. If we see the feedback, Sternheimer Malbin stain is made of crystal violet and safranin, and it is absorbed by cellular elements. Nuclear material and cytoplasm are clearly defined, allowing the identification of white blood cells, epithelial cells, and cast. And this one is the more frequently used. While other stains, Prussian blue identifies iron in cells and cast or free floating in urine sediment. So this used to check or detect iron in cells or cast or free floating. Toluidine blue, as we mentioned before, it is metachromatic stain used to differentiate white blood cells and renal tubular epithelial cells. The acetic acid, it enhances the nuclei of white blood cells and lyses the RBCs. It distinguishes RBCs from white blood cells, yeast, oil droplets, and crystal. Question number 8. A 93-year-old man with acute renal failure was seen in the emergency department. A battery of tests was ordered to include a routine urine analysis, examination of urine sediment using polarized light produce the Maltese cross formation characteristic of oval fat bodies. What stain could be added to the sediment to confirm the presence of oval fat bodies? الجرام stain ولا البروسيان blue ولا الأسيتيك acid ولا السودان 3 oil red? As we know, Sudan 3 oil red is used to detect oval fat bodies. And here is the feedback. Correct answer is Sudan 3. Question number 9. A recent MLS graduated was having difficulty focus the microscope while performing a microscopic urine analysis. The results of the urine analysis are as follows: color yellow, clarity cloudy, glucose negative, protein traces, bilirubin negative, urobilinogen normal, pH 9, blood moderate, ketone negative. And this the strip, urine strip. Okay. Nitrate positive, leukocyte moderate, and specific gravity 1.015. Microscopic result: RBCs 5 to 10, white blood cells 20 to 25, epithelial cells few, bacteria +1. Technologists noted that there were a large unusual objects resembling crystals and possible cast. They were concerned about the unusual microscopic constituents. Our question: what is the possible cause of unusual microscopic constituents? hyaline cast, uric acid crystals, artifacts, broad waxy cast. There is unusual object resembling cast. So, what is the possible cause of unusual microscopic constituents? The correct answer is artifacts. This is the feedback. There is a contamination by artifacts, and the staff have had difficulty focusing because the larger objects were in a different plane from the urinary sediment. The staff must ensure that the examination is being performed in the correct plane. Often, and epithelial cells can provide a point of reference. Focusing on artifact can cause the staff to examine object in wrong plane. So always focus on the epithelial cells, take it as a reference, and then examine the rest of the field. Don't focus on artifact. This is the wrong plane to examine. For the other choices, there was only a trace of protein, which could not be indicative of hyaline or broad waxy cast. And uric acid crystals are seen in urine specimen with acidic pH. The pH of our specimen is 9. So urine is alkaline, so you will not see uric acid. And protein is traces, so you will not see hyaline or broad waxy cast. So the answer here is the artifacts. Always take epithelial cells as a reference to examine the field. Next will be epithelial cells. So follow me to see the next video. Like, share, and follow. Wassalamu alaikum wa rahmatullahi wa barakatuh.